This is one of the most comprehensive videos I've ever created, as you can see by the huge amount of notes I took for this video. I spent over a week reading the Prisma documentation, playing around with examples, and distilling down the most important topics. That way I could include everything you need to know in this one single video, and even though this is a longer video, it includes everything you need to know about Prisma, so you won't need to use any other resources other than this. I also have tons of timestamps in this video so you can jump around to the particular parts you care about, or come back and use this as a reference in the future. With that said, let's get started. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner, and we're going to be talking all about Prisma in this video. Now, you are going to need to have Node.js installed in order to follow along with this tutorial. I have a video covering how to install it. I'll link in the cards and description for you. And you're also going to need to have some type of database installed or a database on a server somewhere. I'm going to be using Postgres for this tutorial, but you can use pretty much any database you want. Just know that if you use MongoDB or another NoSQL database, some things may be slightly different, and that's because Prisma's generally built for, SQL databases, but you can use it with something like MongoDB if you want. Now, to get started with Prisma, what you're going to need to do is you're going to need to download all the dependencies for the project. Before we can download our dependencies though, we first need to initialize npm by typing npm init. That's going to give us a package JSON file, and then we can install our dependencies. So we can just type in here save dev, and that's because every dependency we need for this project is a development dependency. So we need to have Prisma itself, so we can type in Prisma. We need TypeScript, and that's because Prisma is built on top of TypeScript. You technically don't need TypeScript, but we're going to be using it in this project. We have TS Node, which gives you TypeScript definitions for Node. And we're also going to have here @types/node, and that again is helping us with our types in Node. And then finally, we're going to be using NodeMon, which allows us to refresh our server every single time we make changes. So if we make changes to our file, we can click save, and it's going to rerun that code for us automatically, which is really handy. Now, as soon as this is done installing, then what we need to do is actually create a tsconfig file. So I can just come over here, type in tsconfig.json, and this is going to be a file that contains all of our TypeScript configuration. And inside the Prisma documentation, it tells you exactly what you should type in here. I'm just going to copy this over, and this is the documentation that is recommended by Prisma for your tsconfig. Now, if you want, you can go to the Prisma documentation, which I'll link in the description, and it may have slightly different rules, but you can really play around with these rules or use a TypeScript config that you already have in your project. It really doesn't matter. Now, once we have all those dependencies installed and this tsconfig file created, what we need to do next is actually initialize Prisma. So if we type in npx prisma init, that'll initialize like Prisma and the schemas and migrations, all of that for us, but we can also tell it what database we're using by typing in --datasource -provider, and then just type in your database. In our case, we're using Postgres, so we can type in PostgreSQL, hit enter, and that's going to initialize some basic files for us, and it's going to use Postgres by default. So if we open up this Prisma folder, that's what's created. You can see we have this schema.prisma. And inside of here, we have just really basic code. This is going to be your schema file I'll talk a little bit about, but you can see we have a generator and we have a data source. Also, we have this .env file, which contains our Postgres URL. This is going to be the URL to whatever database you're using, so you would need to type in your own specific URL here. And also, we have a gitignore that just contains that env variable and this node modules, just to make sure none of this goes into our GitHub repository. Now, one other thing to note, if we go back to this Prisma file, is you'll notice I have really nice code formatting in here and code highlighting. That's because I have an extension installed called the Prisma extension. If you just type Prisma in, this is the extension you want to look for. It's going to give you syntax highlighting and code formatting. So if I come into that file, let's just go back to it real quick, and I just make some changes, like I add a bunch of, tabs in here, for example, and I click save, it's going to automatically format my code for me, and that's because I have auto formatting set up inside VS Code. But if, for example, you didn't have auto formatting set up, so if I just go into my settings, we'll just come in here, preferences, settings, and I just type in format, actually, I think I need to go edit my settings as JSON here. And if I find Prisma, you can see here Prisma, I have my default formatter set to the Prisma formatter, and I have it set to format on save. If I comment this out and I go back to my Prisma file and I make changes and I save, you can see it doesn't auto format. But Prisma has a formatter built in where you can type in npx prisma format, hit enter, and that's going to format your schema file for you automatically. So you can do both ways of doing this. I obviously prefer to have it inside my settings, which is why I have it auto format on save, just like this. So that way when I make those changes, click save, it automatically formats and I don't need to run that code in the console. Now, very briefly, I want to explain a little bit about what this generator and this data source is before I continue going on in this tutorial. And essentially the generator is what your code is generating into, because this right here is a schema file. You're going to define a bunch of code for your database in this Prisma format. It's not SQL, it's not NoSQL, it's the own format of Prisma. It's completely separate from any other type of, SQL formatting you would think of. So you're going to define your code inside this Prisma specific format. And then when you run your generator, what are you going to generate your code into? In our case, we're generating this Prisma client.js. And this is just the default. We're saying, hey, take all of this Prisma code and convert it using the Prisma client.js formatter, which is the default generator that we care about. And this is what 99% of your projects are going to use. But let's say you're creating like a GraphQL API. There are actually different generators you can use that generate a bunch of GraphQL API code for you automatically based on your schema. So if you want to have an extra step, an extra layer added for like GraphQL, you can do that with a generator. For our example and everything in this video, we're going to be using the default generator because that's what you're going to use 99% of the time. Now, data source, this is pretty self-explanatory. And here we have our provider, which is just where our data is coming from. In our case, we have Postgres. You could use MySQL, you could use MongoDB, whatever you want. And then we have the URL, which is defined in our environment variable right here. Now, this URL, you actually need to make it your actual URL. And in my case, our URL here has a user of Postgres. The password is just password. And then this is 5433. And our database here, we're just going to call test. You can call the database whatever you want. We're just going to be using a database called test. Now, it is important to note that whatever database name you use, that database must already exist. I already have a database on my computer called test. It's just completely empty, and that's what we're using for this project. Now, back to that schema file that we have here, that .prisma file, the next thing we want to do is actually define our schema. And the schema just represents like all of your different data. And we're going to define the most basic schema at first, just to get something started before we start diving into the more complex intricacies of the schema. So we want to create a model, and you just type in model and then give it a name. In our case, we'll create a user model. So we have a model called user, and inside these curly brackets is going to be all of the code for our model. And you can already see we have syntax highlighting saying, hey, you know what? Our model doesn't contain an ID. And every single model inside of Prisma must have some form of ID. So let's create an ID, and we're going to make this ID an integer. So we're going to type in int right here, and we're going to define that it is an ID by putting this @ symbol right here. Now, all of this syntax is fairly confusing to get started with. We're going to deep dive into exactly how this works. But first, I want to just define the most basic model. That way we can see the whole top to bottom workflow of Prisma before we dive deep into each individual section. And the last thing I want to do is define a default value. And this default value, I just want to auto increment. And you can see that we have awesome code syntax suggestions based on this Prisma extension, which makes working in the Prisma environment so easy. So we have a user that has an ID, and we're going to give it a name, which is a string. Now, when I click save, you can see everything auto formats for me, and this looks really good. We now have a user model that's defined in our schema with an ID and a name, super basic stuff, and that's all we're going to do to start here. Now, but defining this model right here, we haven't actually done anything with our database. Prisma and our database are completely separate from one another. They are able to interact with each other, but by defining something in Prisma, it doesn't actually do anything to our database. What we need to do is we need to tell Prisma, hey, you know what? I'm done making changes to my schema. Can you apply them to my database? I want you to migrate my changes from what I had before, which was nothing. I want you to add this new model to my database. To do that, we need to run a command. This command is called npx prisma migrate. And then you can optionally pass in a name as well. And we also want to specify that this is for development only. So we type in dev here. And that means we're going to be pushing a migration that is in our development environment. And we're going to give it a name of init because we're initializing our database with this new model of user. We click enter and it's going to run through a bunch of code. Essentially, it's going to create a brand new migration file. And that migration file is going to be able to interact with our Postgres database and make all of these changes. And you can see right now it just did that. Your database is now sync with your migration here. And we have this migrations folder. If I open it up, you can see inside of here, we have a SQL file that contains our migration, which just says, hey, create us a table. It's called user, give it an ID and a name, and a primary key of ID, which auto increments. Really basic stuff. You'll also see something really important here. It says generated Prisma client, and it says put it in my node modules folder at Prisma/client. Essentially, we have created a brand new Prisma client. And this client is that thing from the generator. We're saying, hey, create me a Prisma client.js. Whenever I change all my code and I make changes to my database, such as adding this model, I want you to update my client code, which in our case is this Prisma client. And that's what it does. Every time you make a migration, it's going to update your client for you. And that client is essentially all of the code for interacting with your database. Now that we've added this user model, our client added a bunch of code automatically for us that allows us to interact with users, create them, read them, update, delete them, and so on. And all of it is typed with TypeScript, so we have this nice type safety blanket. Now, unfortunately, we don't actually have a client yet because we haven't installed the client library. So we need to do that now. We can type in npm i at prisma/client, and this is going to install the client that allows us to actually generate and use this client. And when we first install the client from doing this migration, we already have everything generated, but if you need to manually regenerate your client, you can type in npx prisma generate, and what that's going to do is it's going to go through all the steps of generating based on whatever provider we want, which is the default one, and you can see that now we can start using our Prisma client because it automatically generated it for us and stored it in that particular location. And again, that's all of our Prisma code in that one place. So let's just copy this little bit of code it gave us, and we're going to create a brand new file called script.ts. And inside here, I'm just going to paste that code. And this allows us to access our Prisma client. So now we can type in, for example, Prisma dot, and you can see we have a bunch of different methods as well as this user right here. And user represents that user table we created right here. It's automatically generated for us. So we can say .user, and you can see we have a bunch of different methods. For example, we could do like a find first to get the very first user based on different criteria we pass it. Now I'm just going to paste in a little bit of code right here, and this code is essentially just a really simple way of using async await. We just created a function, an async function, called it main, and then down here we're catching any errors and printing them out, or at the very end we're finally disconnecting. So as soon as we're done running all of our code, we're disconnecting from the Prisma database, and that's something you don't have to technically do, but it's probably a good idea to disconnect when you're done, but it'll automatically disconnect for you as soon as your program finishes running. So in our case, it doesn't really matter because it would automatically disconnect, but adding this in there is also just fine. So now inside main here, we can write any of our Prisma code. And the reason we put this in an async function is because almost everything in Prisma is asynchronous. So it's going to run, it's going to wait, and then it's going to give you a result. So using async await makes it easier to work with. And if you're unfamiliar with async await, I have a full video covering it. I'll link in the cards and description for you. So what we can do inside of here is we can say prisma.user, and let's create a brand new user. We'll just say create, and we're going to pass in data. That's how we specify what we want to create. We say data, and we pass it an object that contains all the data we want. In our case, we have a name. We can say name is going to be Kyle, just like this. Now this is going to create us a brand new user. And if we make sure we await this by just saying that we're going to have a user, and we're going to await right here, we can console.log out our user. So we're just waiting for Prisma to create a user for us. It's going to put it in our database with the name of Kyle. It's going to return that user, and then we can log that user out right here. So in order to run this program, let's go into our package.json. In our scripts section, let's create a script called dev start. I'm just going to say nodemon script.ts, and that's going to automatically compile and rerun our script.ts file every time we make changes. So I can type in npm run dev start, which is that title or that script we just created, and it's going to start up TS node. It's going to run, and you can see it just created a brand new user named Kyle with an ID of 1. Let's say we want to create Sally. I can come in here, change the name to Sally, click save, and now we have an ID of 2 with the name of Sally. Super straightforward. Also, if we wanted to get all the users, we could just say, for example, find many, and we can come in here and we can just say this is going to be all of our users. Click save, and that's going to generate all of our users. You can see we have our user Kyle and our user Sally. And that right there is like the basic overview of Prisma from top to bottom. At the very top, you create your schema, and the schema defines the data source you're using, so your database. It defines the generator for how you go from your schema to your TypeScript code, and it defines all of your different models and enums and everything related to your database, all inside this one file. Then, once you're done with that, you create your migrations, and your migrations allow you to make changes to your database based on the changes you made in this file. So when you update this file, it'll automatically create a migration that moves you to the next step, so your database is always up to date with this file. Also, in doing that migration, you're updating your code with this generator. This generator creates a library for you, this Prisma library right here, that allows you to interact with your code through this Prisma library, so you don't have to write raw SQL queries. So this schema file essentially defines your entire database. It allows you to migrate your database, and it allows you to interact with your database. This is like your single source of truth and is really important to understand. And that's why in this next step of this tutorial, I'm going to be covering everything you can do inside this schema file for Prisma, and it is a lot. Now, first, I want to go a bit more in depth on generators and data sources before we really dive into the complex part, which is our models. So when it comes to data sources, you can only ever have one single data source, and that's because Prisma is directly connecting to your database. So you can only have one database that defines all of your data, so only one data source, and it must have a provider, which is the name of your database you're using, and it must have a URL which links to that particular database. Also, it's really important that you use environment variables for storing your database URL. That way all of your password information is safely secure inside of this file, and you can also change the database that you're using for development, staging, and production, and so on. Now, the next thing that we have is a generator, and you can have multiple generators. For example, we could have a generator for our Prisma client, and we could have a generator for some type of GraphQL API. There's tons of different NPM libraries out there for different generators, so you can take a look at them if you want, but in our case, we're going to be using just this one generator. Now, in order to define a generator, all you do is you give it the provider, and the provider just links to the name of that generator, and whatever generator you want will tell you what the code here should be for the provider name. So now let's move on to the more complex part, which is models. Models essentially represent the different tables inside your database where you can store your data, and each model is essentially composed of a bunch of different fields. Each row you see right here is considered a field, and a field is composed of 4 different parts. The first part right here is just the name, really straightforward. This is our ID field. This is our name field. We could have, for example, an email field just like this, and that's just the very first part here is the actual name. Then the next thing that we have after that is going to be the type of that field. So we have an integer, here we have a string, and so on. After that, we have 2 different things that are optional. So you are required to put a name and a type on everything, but optionally you can have a field modifier and you can have attributes. So a field type modifier would be like saying, hey, you know what? The name is optional. So we're going to put a question mark here, and that says that this name field is optional. We're going to cover all the different type modifiers in a little bit, but that's what those would look like. And then attributes are all these things that start with the @ symbol. For example, we're saying this is an ID field. We're giving it a default value. Those are all your different attributes. And again, they're optional. Our ID field has a bunch of attributes, but our name and email field do not. So now let's dive into some of the different types of fields that we can have. I'm going to cover every single field type that's possible. So far, we've covered the integer field type and the string field type, but there's a ton of other field types. For example, let's have an isAdmin field, and this is going to be a Boolean. So we just say our type right here is Boolean. That's going to be one more type that we can cover. Another type that we can cover is something called a big int. For example, if we had like a large number, and this is a super large number that we wanted to be able to like finely tune and cover, that's going to be larger than a normal integer, you would want to use a big integer to represent that, and we could just type in big int here. We don't really have anything that would be big int related in this application, so we're just going to remove that for now. Another type of field that you could have would be a float. I'm actually going to create a new model, and this model is going to be for a post. And this post is going to be like a blog article that someone wrote. And this blog article can have a rating, so like a 5-star rating. And this rating can be anywhere between 1 and 5 stars. So maybe it's like 4.7. Well, we know that this is going to be a decimal value, so it's going to be a float. And that's because a float essentially represents a floating point number, or a number that has decimal places. There are also different types of floats that you can have. For example, you could have a float or a decimal. These are both very similar in that int and big int are almost the same thing. A float is kind of like less specific. It's a more general floating point number, while a decimal can represent a much wider range of floating point numbers. So if you need to be really accurate with your floating point numbers, decimal might be the way to go. Otherwise, for most use cases, float is going to be just fine. Another type of field is going to be a date-based field. So for example, we could have like a created at, which is going to be a date time, and we can have an updated at field, which is also going to be a date time. Date times just represent essentially a timestamp, so like a date and a time. That's all they are. It's the only time-based type that you can use in Prisma. Now, those are most of the main data types you're going to use, but there's a couple other unique ones that you might run into. For example, you might have like user preferences. So we could say preferences, and this is just going to be a JSON object, so we can use the JSON data type to represent that. Not all databases support the JSON data type, but Postgres, for example, does, which is why we can use this. If we were using something like SQLite, for example, as our database, you can see immediately we're getting an error that says, hey, JSON's not supported in that database. So it's really nice that it takes care of that for us. Another type that you're going to run into is the type of bytes. So we could come in here and, we could say that we want to have like a blob, and this is going to be a type of byte. So like if you're storing like file data or like really big data that you need to convert down to just raw byte information, you could use bytes to store that. A lot of times you're not going to really run into this data type that much, so it's not super important. Another data type that you might run into is the unsupported data type. And this is a really interesting data type in that it is not something you're going to ever write yourself inside of a Prisma schema file, but Prisma allows you to actually take a database that already exists and convert it to a schema file. And since Prisma doesn't support every single type of data type in the entire world, there are going to be some that are unsupported, so it'll list them as unsupported if you take an existing database, convert it to Prisma, and it does not support that data type. But if you're just starting out with Prisma, you're never going to use this data type at all. Now, the last type of data that you could run into would be like data that represents another object. For example, if we have a post, we could have an author, and that author could be a user. Now, in order to define this type of relationship data, you actually need a lot more information than just writing out there's an author with the type of user. So when I click save, you're going to notice it's actually going to auto-populate a lot of information for me. You can see I click save, and automatically it added this post reference inside of our user, it added this user ID, and it added this author tab right here, which has this huge relationship section. This is essentially how you make different relationships inside of Postgres. And I'm going to cover the 3 different types of main relationships you have. You're going to have a one-to-many relationship, which is where, a post has one author and a user has many posts, one-to-many. We're going to have many-to-many. For example, one post could have a category, and a category could have many posts. So each post has many categories, and many categories have many posts. So there's a many-to-many relationship there. And then also I'm going to be covering what happens in a one-to-one relationship. For example, if a user has like a table of preferences, each user has one reference in that preference table, and each preference has one user it links to. Those are the 3 different types, and we're going to cover all 3 of them here. So the first one is one we've already started to cover, which is a one-to-many relationship. So a user is going to have many posts. So what's coming here, we're going to say that many post, and it's going to be a post array. And this array syntax right here is a field type modifier. And there's only 2 modifiers you need to know of. There's the array one, which says there could be multiple of this thing, and there's question mark, which says it is optional. Those are the only 2 field type modifiers out there, and you're going to see them all the time. So we're saying each user has multiple posts, and they are the type post, and there's an array of them. And then inside of here, our post has this relationship. The field right here is referencing what field inside of our post table is referencing the ID inside of our user table. So we're saying that the user ID field in our post right here references the ID field in our user, and those 2 should be the same. So whenever the user ID is the same as the ID, that means they are linked together. It's like a foreign key relationship if you're familiar with SQL. Now in our case, we want this to say author ID. So we can change that to author ID instead of user ID. And now that's going to link this author ID column with the ID inside of our user table. Another thing that I want to show you is that you can use more than just auto incrementing IDs. You can actually use UUIDs as your ID, which is something that I find a little bit more common to use UUID instead. So we can just type out UUID right here and make this a string type and move this down here as a string type. And now we're going to have UUIDs instead of auto incremented IDs. And that's just going to be a little bit more secure because people can't just change the ID from 1 to 2 and access new information. UUIDs are completely random and unique. Also, our post should have its own ID, so I'm just going to copy this down, and we're going to give our post an ID to get rid of those errors that we had. Now that right there covers how to do a one-to-many relationship. What happens if a user can have 2 references to a post? For example, we're going to have posts that they wrote, so we're going to have written posts, and we're also going to have favorite posts. So for example, they favorited some post, so we're going to have favorite post and written post, and both of those are going to be a reference to post. And then down here, we're going to have both a author, and we're also going to have, I'm just going to copy this real quick, a favorite. So we can say favorited by and favorited by ID. So now this is saying that a post can be favorited and a user can have multiple favorited posts and multiple posts that they have written. But you'll notice we get an error. Essentially, we're saying, hey, we can't, validate this because it's ambiguous. Which one is written post, which one is favorite post, because they don't actually say. And we just make sure we update this right here to be favorited by ID. These relationships both point to the post table, but we don't know which one of these relationships it's pointing to. We need to give these relationships a name. So we can pass in a first property to this relationship function. We can just say written post, name it whatever you want. It doesn't matter. This is just a label. And this label can be shared with all of the other fields. So up here, we can say at relation, and we can say that this is going to be a written posts. And down here, this is our favorite posts. And our relation for this one is going to be that favorite post. So what we've done by this is by giving these names is we disambiguated it. We've said this written post array right here references this author and author ID section, while this favorite post references favorited by and favorited by ID. So you only need to do this extra step is if you have 2 references to the exact same table. Normally you don't have this, but in our case, we do have this scenario. Also, before we move on, I'm going to make this user field right here for favorited by optional. So I'm just going to come in here and put a question mark to say, you know what, our favorited by is optional. We also need to make sure our favorited by ID is also considered optional because both of those fields are linked to the same thing. So that right there covers a one-to-many relationship as well as disambiguating multiple one-to-many relationships. But what happens if we have a many-to-many relationship? Let's say that we have another model called a category. In this model category, we're just going to give it an ID. I'm just going to copy this ID over here. So we have an ID and it can have multiple posts. So for example, we'll say post, is equal, or sorry, not equal, but we can have this post array. So essentially one category can reference multiple different posts, and a post can have multiple different categories. So we can say category array. And if we save, you'll notice we don't need to do any fancy @relationship setups. It just automatically knows that our categories right here is referencing this category model, and this post right here is referencing our post model. And it's automatically going to create a join table between the two that is going to hook up all these relationships for us. So all of that complicated join table stuff that you would normally have to do for many-to-many relationships is taken care of by Prisma, and you don't need to worry about it at all. So right here with this little bit of code, all of our posts can have multiple categories, and all of our categories can have multiple posts. Now the final type of relationship I want to talk about is a one-to-one relationship. So we're going to say one user is going to have one set of user preferences. So instead of using this JSON right here, I'm going to bring this into its own table. So we can say we're going to have a model called user preference, just like that. And this user preference is going to have an ID. So let's just paste in an ID. And we're also going to give it a field like email updates, for example, which is a Boolean. So we're saying, hey, you know what? Do you want to receive email updates or not? That's all this is saying. And now we want to reference the user table from our user preference. Now, since we're doing a one-to-one relationship, you can store the relationship on either the user table or the user preferences. In our case, I'm going to store it on the preferences. So I could just say user is at our user table, and we can also have a user ID, which is for that user table. This is just a string. And if we save this, you can see it automatically does a lot of that relationship for us. And we don't want this to be an array though. We want this to be a one relationship. So we can just put a question mark here. We're saying optionally, this is going to have a user preference just like that. And you can see here, this automatically marked itself as unique because this user ID must be unique. The reason this must be unique is because we can only ever have a preference reference one user. We can't have multiple preferences referencing the same user. That's how this one-to-one relationship works. Now, speaking of this like @unique attribute, let's actually talk about a lot of the different other types of attributes besides the relation attribute. Because so far we just talked about relation, ID, and default, but there's a ton of other attributes out there. And one of them is the unique attribute. For example, we want our emails to be unique. So we can just put an @unique on our email, and now every single email is going to be unique. Now the last kind of attribute I want to talk about, at least field-based attribute, is going to be the updated attribute. Down here we have this updated field, and if we give it the attribute updated what that's essentially going to say is that every time we update this post, it's going to automatically set this updated field, whatever we specify as updated as the current timestamp. So it's automatically going to update that for us. We don't have to worry about manually keeping track of that updated time, which is super cool. Also created we should probably give it a default of now. So we can just say default now, and that's going to default to the exact current timestamp when we create this. So that way when we create this, we don't have to worry about manually setting this time. Now, before we start talking about the last set of different attributes, which are block level attributes, I want to define a few additional rows to all of our different tables. So for example, we're going to give each one of our posts a title, which is going to have a string. We already have our rating. I'm going to change this to average rating just because it makes more sense with that float specific type. We have our created we have our updated we have our author, favorited by, favorited here. All of that is looking really good. Down here in our category, I want to give this a name, which is a string, and up inside of our user, I want to give our user an age, which is going to be an integer. Also, down here, I want to make this unique. So we're going to say that our name is unique. So that's going to be like the basic bare bones of our schema, but there's something else we can do besides just these single field level attributes. We can actually do block level attributes. Now I want to discuss a little bit the difference between the two. A field level attribute applies to the field. As you can see, our ID has the ID attribute. It has the default attribute. They're in the same row as our field, and they also have one single symbol in front of them. Now a block level attribute goes inside of these curly braces, and it's on its own line completely, and they have two symbols in front to represent that this is a block level attribute. For example, what we could do inside of here is we could create a block level attribute on uniqueness, and we could say that inside of here, we must have a uniqueness constraint on age and name. We cannot have two people that have the same age and name. So we could just say age, name, just like that. And now what this single line of code right here is saying is that inside of our field, we must have our age and name be unique. And let me just get rid of those quotes. That was an accident on my part. So now we cannot have two users that have the same name and the same age. We can have two users that have the same age and different names, or the same name and different ages, but if you have the same name and the same age, it's going to throw an error because we have this uniqueness constraint. We could also specify an index. So I'm going to come in here and I'm going to say we're going to have an index. And let's say that we want to create an index on the email field. So we could have an email index. And this is going to help with things like sorting and performance. And we could also index on like email and name if we wanted, for example. But in our case, we're just going to index on email because what if we want to like query by email? It would be good to have an index on that. Now, the last type of block-based attribute I want to talk about is going to be the ID attribute. So if we come in here, we can actually create an ID attribute. And if we just comment out the ID up here, we can create a composite ID. So essentially an ID that contains two different things. So here our ID could be an ID that is on the title, and it could be on the author ID. So now we're saying that instead of having a specific ID, we're saying that our title and our author ID represent our ID for the post. So we must have a unique author and title combination, and that'll be corresponding to our ID instead of having this auto-generated ID up here. Now in our case, we don't actually want this, so I'm going to remove this, but I just want you to know that this is an option that is available. Now that pretty much covers 99% of everything you need to know about models. There's really not much else to learn, but there is one other type of, data source generator model that we want to talk about, and that is an enum. So if we come down here, we can create an enum, and this enum we're going to call role. Now this role enum is going to have two values. We're going to have basic and admin. And right here, that'll help us define how our user is. Is there an admin or not? And this is admin field. Let's actually just get rid of this and replace it with a role, which has the type of role. And by default, we want them to be a basic user. Now we have a bunch of different roles, and as we add more roles, we can come in here, we can say like, oh, we now have an editor role, for example, and that's just going to be defined inside of this enum. And this is really nice if you know a field only has a few set values that it can be, like basic, admin, editor. If you define an enum, it's going to make sure that when you actually start writing out your code, it'll only allow you to specify one of those specific values instead of just any value at all. So if you have a hard-coded list of values that something can be, using an enum is a great way to do that. So that right there covers everything you need to know. I mean, we covered models, data sources, generators, enums. It's everything you need to know about the Prisma schema. And if there's anything else that you need to know beyond that, it's super niche and you're probably not going to use it very often. So now that we have our entire schema written up, let's actually migrate our database to include all this new information. We can type in npx prisma migrate, and we could say dev, and if we don't give it a name, we just hit enter, it'll just ask us to specify a name. So if we just give it a second here, it's going to ask us to specify a name, and we can just give it any name that we want. But it looks like we actually ran into an error. If I scroll up here, it says we found changes that cannot be executed. It's trying to add the column age, which is required, but there's no default value, and there's two rows in our table that have that value. So this is nice. It's doing validation for us, being like, hey, you're trying to do something, but it's not going to work. So for now, what I'm going to do is I'm just going to go into our script file here. I'm going to delete everything. So we're just going to see. We're going to delete all of our users because we don't actually need them. It's fine. We can get rid of them just to start at a clean slate. npm run dev start. If we just run that, that should hopefully delete everything from our database. And then when we run our migration, it'll hopefully work just fine. So that ran everything. And now what we can do is run our migration. And hopefully we should no longer have any errors because those users that we created when we were testing are no longer there. And then it should ask me for a name. As you can see, are you sure you want to create and apply this migration? It's just saying a unique constraint on this table will be added. If there are existing duplicate values, this will fail. Same thing here, unique constraint. If there's existing values, it'll fail. We don't have any, so it's fine. Enter a name. We can just say test, whatever you want for the name, it doesn't matter. And now that created our migration and generated our client for us. We go into our migration folder here. You can see there's our first migration and our second migration. Obviously, this one is much larger because it essentially creates everything inside of our schema file. And it's nice because all of this code is kind of cumbersome to write, but the nice thing is the schema file defines it all for us. So now we are finally able to move on from this Prisma file and we can move into our actual JavaScript file and we can start talking about all the different functionality that Prisma provides us. And we're going to be talking about creating, reading, updating, and deleting. Now, first, I do want to say just a few little minor things about Prisma that are important to understand is that when you create this new Prisma client, this actually manages different connections for you. So if your database supports up to like 5 concurrent connections, this Prisma client will handle all 5 of those connections for you. So it's really important that you only use one instance of this Prisma client and you don't create a bunch of them. Otherwise, you could bog down your database with too many connections. Now, with that said, let's actually start writing out our Prisma code. Let's create a user. We've kind of already looked at the create function, but let's really dive into how it works. We're going to come in here, we're going to create a user with some data, and you can see when we auto-populate, we have a name and an ID. And it looks like our code is not actually generated. So we need to rerun that generator again just to make sure everything works. So let's just type in npx prisma generate to make sure that our generator works to actually generate all of our code. We'll give it a second to actually run. There we go. So now it should hopefully have generated. Click Control Space. It still hasn't generated. Sometimes you will run into this problem. I found the best way to do this is either just close out of your file and then reopen the file back up. That may fix the problem. If we come in here, click Control Space, you can see it still hasn't updated it. The next best option is hold down Control or Command if you're on a Mac and just click on the function you're trying to go to. And inside of here, you'll hopefully see that it actually opened up a TypeScript file. And this TypeScript file contains all that information. When it opens that up, it's going to reload all your TypeScript. And now you hit Control Space, you can see all of our information is there. So if for some reason generating it doesn't actually fix it for you, just try those steps and it should hopefully auto-populate. Worst case scenario, just close VS Code, reopen it, and that'll definitely work. And since you don't run migrations very often, it's okay that this is a little bit cumbersome. So as you can see, based on this, our age, name, and email are required and everything else is optional. So let's give it a name of Kyle. We're going to give, an email of kyle@test.com. And we'll say age is 27. And we'll just get that user and we will console log the user. So now if we run npm run dev start, just give it a quick second here, and we hopefully should see we have that user being printed out. There we go. We have an ID, an age, a name, an email, and the role is set to basic. Now, if I save this file again, it's going to rerun it, and we're going to get an error. If I save, you'll see we get an error because our email is the same. Unique constraint failed on the field's email, and that's because we're trying to create a brand new user with the name of Kyle. And that's why at the very top here, what I'm going to do is I'm going to await prisma.user.delete many. And that's just going to delete all the users that are currently in our database. So that way, every time we save, we start over with an empty database to make sure we don't run into any of these uniqueness problems. And that's just going to be purely for me to show you how Prisma works. Obviously, you wouldn't do this in a real scenario. Now, you did notice if I click Control Space here, we can actually specify data for like favorite post and user preferences, which is kind of interesting because these are actually models that are not directly on the user. These are models that the user references. But with Prisma, we can actually do all that nested creation all in one create function. So let's say I want to specify some user preferences. I can say our user preference is going to equal an object. And inside this object, we can use the create function. And the create function is going to allow us to create a brand new user preference. So we're going to say create here. And inside of create, I want to say that our email updates is going to be set to true. We want to receive email updates. Now, when I click save, and we just give it a second, you're going to see it created as a user. But we didn't actually get any information from that user returned about their preferences. You can see we just have, ID, email, name, and so on. If we actually want to get their email preferences returned, we need to pass another property to our crate. You can see we have include and select. And by going into include here, what I can do is I can say, you know what, I want our preferences, our user preferences, to be included. So I'll say true. Now when I save that again and rerun, you'll see we're of course getting an error, delete many invocation. It's saying foreign key constraints failed on the field user preference user ID key. So the reason we're getting that, if we go back to our schema here, is just the way we defined our user and user preferences. We're trying to delete this user, but this user is referencing this user preference, and it's not allowing us to delete the user preference because of the user. If we swapped around where we are storing our foreign keys, that should solve the problem for us. So let's do that real quick. I'm just going to take this, move it up to here, move this down into here. So this is going to reference a user, and this is going to reference a user preference ID, just like that. And this will say user preference ID. Get that all fixed around. And this right here, we want these to be optional. And down here, we're going to make this not optional. And then if we just change this to user preference, and then get rid of this auto-generated stuff that populated. We don't actually want any of that auto-generated stuff. Get rid of that there. Hopefully that works. Finally, to get rid of this error, we just want to make this optional down here, and that'll give us a working version. There we go. So now we're just saying that our user can optionally have a user preference, and we need to rerun our migration. So let's just come in here. We'll say migrate dev, and we're going to give it a name of test2, just to get it to run for us, essentially. So give that a second. That should hopefully run for us. And the reason we're doing this again is so that we have this so that it actually do our deletion. So when we delete our user, it'll also delete our user preference as well. So now we can come into our script ts, and if we just npm run dev start, it should hopefully delete that user, and then now you can see it created a brand new user. But most importantly, since we included our user preference here, you can see our user preference is showing up in our results. So by using include, we can include essentially different references inside here. Also, instead of using include, we can replace this with a select. And a select can do a lot of things. For example, we can say, you know what, I want to get just the name. So now when I run this, it's only going to return to me the name property and nothing else. Or I could say, you know what, I want to get my user preference. So I'll say that user preference is true. And it's going to return to me a name as well as all the user preference information. Or maybe I want to get a little bit specific. And instead, I want to select only the ID of my user preference. So now I'm getting just the name, and then I'm getting the ID of my user preference. So you can nest together these selects and includes, but it's important to know that you can only do either a select or an include. You can't do both at the same time. It's only one or the other. Now, in order to actually understand what's going on behind the scenes with Prisma, we can come up to our Prisma client here. We can say that our log here, we want to log out all of our queries. So we can just give it an array and put query into there. So now every time it runs a query on our database, it's going to log that query out. So you can see here we have this massive list of all the queries that are being run. We're doing a bunch of select queries for our delete. So this is how our delete works right here. And then we're doing a create query right here that creates our user preference. It creates our user, and then it selects our user and our user preference based on our select section right here. This is kind of neat if you need to debug things or worry about performance. It's nice you can actually log out the queries. I'm going to get rid of this because it's obviously polluting all of our logs, which is not something that we want. Now, something else we can do is a create many. So create many is just like create, but you pass in an array of data. So instead of our data here, we're going to pass it an array of data instead. I'm going to come in here. I'm going to create a user called Kyle. And I'm going to create a brand new user, and we're just going to call them Sally. And we'll say that they are 32. And it's important to note that inside of a create many, you can't actually use this select clause. So we're just going to get rid of that select clause, and we're going to change this to users. Now when we click save, this create many is going to create 2 brand new users, and you can see it returned a count of 2 to say that it created 2 users. Now this right there covers creation, but what if we want to do finding or reading of data? I'm going to get rid of this delete many right here, and what we can do now is focus on the actual reading of data. So instead of create many, I want to say find unique. And find unique is interesting in that it allows you to find things based on unique keys inside of your database. So if we go over into Schema Prisma, you can see we have a lot of things that are specified as unique, such as our email, our ID up here is specified as unique. So we can actually use those uniqueness IDs to find different pieces of data. And this is going to return to us one single user, because find unique always returns 1. So inside of a find query, we always have the ability to do a where. And inside this where, you can see we have options for our email, our ID, and then this thing called age name we'll talk about in a little bit. So let's say we want to find the user that has the email of kyle@test.com. Type that in, you can see it found that user right here. Also, we can pass in select or include if we want, exactly the same as how we did with create, so I'm not going to cover that again here. Now you did notice that if I come in here a second, you'll see we have this age name property. That's because in our schema, we defined a unique key on the age and the name. So the way Prisma defines this is whenever you define a uniqueness constraint on multiple fields, it'll specify them just like this with underscores between the names. And then what you need to do is just pass it an object that contains both your age property, which in our case is 27, and the name, which is Kyle. And now it's going to find the user that has that unique age and name combination. Click save, you can see it found that user. If we had one of these incorrect, and we click save, you can see it's going to find nothing because no user has this age and name combo. Now you will notice though in our where clause, we can't search for things like just name, and that's because that doesn't have a uniqueness constraint on it. There's nothing that just says the name must be unique. If we want to search for just a user based on name, we would need to use one of the other find queries such as find first. Find first will just find the very first thing that matches a query. So we could say where the name is Sally, and now this is going to find the very first user with the name of Sally, as you can see just like this. Now find first, very similar to find unique, but it allows you to do any property. For example, if we come in here, you can see we have all these different properties we can do our where query on. Now we also have find many. We could say find many, and it's going to find us many users that match this. So if we hit save here real quick, it's going to return to us just one user because only one user has that name. But you can see we have an array which contains that Sally user. Now, the next thing I want to talk about before we start talking about all the different complexities of this where filtering is things about filtering and distinctness. So what we can do, I'm going to comment this out. I'm just going to create 2 new users real quick. So we'll say await prisma.user.create many, and this many is going to have some data. And inside of here, we're going to have a name of Sally, age of 12, and let's see here, email is sally@test1.com. Save that. So we've created that user. Let's create another user here, just like that. We're getting some errors, it looks like. It's because this console log needs to be removed, but it did create those users. If we save again, it should hopefully give us a uniqueness constraint error, I believe. It did not actually, so let's create Sally12. There we go. So now if we just get rid of this code and bring this code back in, we should hopefully now have 3 Sallys being returned. Let me just bring this up. You can see, if I just rerun that real quick so I have my formatting correct, that we have a Sally which age 32, age 13, and age 12. We have 3 different Sallys being returned by our find many here. So if we want, we can actually modify this query to do things like pagination and distinctness. For example, I could say, you know what, I want to get it where the name is distinct. So I could say, you know what, wherever the name is distinct, I want to get Sally's. So now it should only return one single Sally because they all have the same name. So when I say distinct on name, it's only going to get the first Sally with a name. We could also do distinct on things like name and age. And now it's going to get me every Sally that has a unique name and age, which it returns all of them because the name and age is different for all of them. Now, a little bit more important than distinctness is going to be things for pagination. So pagination, you can say take, and this determines how many you want to return. For example, we're going to say take 2, and this is going to return to us 2 users. If we scroll down here, we get the Sally with the age of 13 and the Sally with the age of 12, so it's returning to us 2 users. We can also combine this together with something like skip. We can say skip 1. So now we're skipping the first user Sally and getting the next 2. So we're going to save that again real quick, and you can see we get the Sallys with the age 12 and 32, and we skipped that very first Sally with the age of 13. We just have the one with 12 and 32. So you can combine together this take and this skip in order to get these different Sallys that you want. You can also do an order by. So we can say, for example, we want to order here by the age, age, and let's do that in ascending order. So now we're getting only the last 2 Sallys in order by age, so it gives us 13 and 32. If we sort it in descending order instead, it's going to give us 13 and 12 because those are the youngest 2. So now we get to the fun part, which is all of the different where clauses that we can do. Right now we've covered the most basic types of where clause, where we just say the name is equal to Sally. And another way you could write that is by putting this inside of an object and saying equals Sally. This right here is going to be the exact same where clause. It's going to give us 3 users. And I believe here we can get the count if we want instead. So we can just do that by saying user.length down here, and they'll just return to us however many users we found. For example, we found 3, and that's because 3 users have the name of Sally. We could also do a lot of other things. We could say, hey, you know what? We want to get where the name is not Sally. This is the exact same as not equal. So we're saying it's not Sally. There's only one user that does not have the name of Sally, and that user, if we save this again, is the user that has the name of Kyle right here. We can also use in, and that's going to say, we're going to pass it an array, and it's going to give us all the users that have a name within that array. So all the users that have the name Sally or Kyle, and as you can see, that returned all of our users because every user we have has the name Sally or Kyle. We can also do the opposite by saying not in. So I want to get all the users that don't have the name Sally or Kyle, and we get an empty array because all of our users have that name. Now, if we want to take this a step further, we can specify we want to do a query on age. For example, we want to do where the age is, let's say, less than 20. And let's comment out this name query up here. And now we're going to get all the users where the age is less than 20, which is just these 2 Sallys. We could also say, for example, where our name is equal to Sally, and this will allow us to do like a type of and query. We say Sally right here. This is now going to get all the users that have the name Sally and have this age less than 20. If I try Kyle here, you'll see it no longer returns any users because no user has the name Kyle and an age less than 20. If we did greater than though, you'll see that now Kyle has an age greater than 20, so he shows up. We could also do greater than or equal to and less than or equal to for queries as well on numbers. Now, another important query we want to do is a query on contains. So contains allows us to check if the text is contained inside of another piece of text. So we could say that our email contains the text at test.com. This is going to give me every single user that has @test.com inside of their email, and all of our users have that. Well, actually not all of them, only the first Kyle and Sally were created. If we want and @test1.com, we'll get the Sally that has that @test1.com at the end of their email. And if we want to be even more specific, we could use ends with, and that's only going to see if this string is at the end. So for example, here we have @test1 at the end, or we could say starts with, and we could, for example, say we want it to start with Kyle, and now we'll get all the users that email starts with Kyle. Now that covers all of your basic types of queries for where, but you can also combine these with ands, ors, and nots. So we covered already how to do a basic and by just, saying name right here would be like Sally, for example. And since no user has the name Sally and an email that starts with Kyle, we get this returned as nothing. We could combine this by just saying and like this, and then we can give it an array. And inside this array, we just put all of our different queries. So we, for example, have one query that is going to be our email. So I'm going to put that inside of an object, just like this. And we're going to put this name query up inside of here as well. Now, if we save, you can see that this is going to work and it's going to return nothing. But if we change this to Sally, for example, it will work because it'll return all of our users that have Sally at the start of their email and the name of Sally. Now, really the only main time you would want to use this is if you want to do a query on like email multiple times. So for example, we want to come in here with our email property multiple times, and we want to check where it starts with Sally and where it ends with @test1.com, for example. And this will return to us just the one Sally that has that email. We could also do an or query. For example, we could say where the email starts with Sally, or we'll say, let's say age is greater than 20. That's going to return to us all the Sallys, and it's also going to return to us the Kyle user because their age is greater than 20. Finally, if we wanted, we could do a not query, and a not query works very similarly to all the other queries. It just negates everything inside of it. So let's just come in here. We're going to say where the email right here does not start with Sally. Click save. And now we get just the Kyle user because it's the only one that doesn't have an email that starts with Kyle, or starts with Sally, sorry. Now the next thing I want to talk about is how you actually do queries on relationships, because you will know that we can do queries here on our relationships. For example, I could do a query on my user preferences. And if I look inside this user preferences, you can see we have a lot of the same stuff that we had with our queries before. So for example, I could say, hey, where our email updates is true. Now, if I click save, console log out all the users where email updates is true, we just get an empty array because currently none of our users have email updates set to true, which is fine. Now, if we wanted to do a query on something that's more than just a one-to-one query though, we could actually do that. We can say, let's check all of the written posts. And inside of here, we can either do an every, a none, or a some. So we can check where every written post has this query, none of them have this query, or some of them do. For example, we could say where every written post matches this section. So let's say where every written post has a created at that is some new date, like the current date, for example. This would be a bad query, but it's a good example of what could happen. Or we could say where the title is equal to test. So I want to say, is every single post that this person written start with the title of test? If so, return that user. Now, when I click save and run this, it's going to be essentially every user. And the reason it returns every user is because none of our users have any post at all. So technically, all of their posts start with the test of title because none of their posts, they don't have any. So technically all of them specify this requirement because there are no posts at all. We could also come in here with a none, say, hey, has this user written no posts that have this title? And again, it returns everything because no one has any posts. That's perfectly okay. Then we can do some to say, hey, do any of their titles start with test? And this one returns nothing because currently none of our users have any posts, so none of them actually have this title to be used. Now, obviously, these queries are much more useful when you have all of this relationship data going on, but this is just showing you what you can do with these queries. And also, you can do all the fancy stuff. We could do a starts with here. So we could do all of the fancy querying that we were doing before and nest it as many levels deep as you want to. It's going to work just fine. So all of the different queries we talked about, they can be nested infinite levels deep. It's just important to know that we have the sum, the every, and the none that you need to worry about when they're doing posts like this. Now there's one other type of query that we want to talk about with relationship filtering. So let's actually check to get our post here. I want to find many posts where the user here, so our author ID, or actually let's just do author. And here we have slightly different information. We have is and is not. We can say is, we can check, hey, is this a particular author? So here I could say is, and then we can pass in like age 27. This is going to give me all the posts where the author has an age of 27. Pretty straightforward stuff that we can do. And this is nice because we can combine it together with an is not as well if we wanted to do like the opposite of an is. Now that right there covers everything you need to know about reading data. So we have all that fancy filtering stuff. We have pagination, relationship filtering, and so on. Now I want to talk about updating. So let's come in here. We're going to do this on our user, for example, and we have two functions. We have update and we have update many. They both work almost exactly the same. It's just that update will only update the first user it finds, and update many will update every user it finds that matches the data. So update is going to take in two sections. We're going to have a data and we're going to have a where. So it combines together our find and our create. So our data here is just going to be the data that we want to update. For example, let's change our email from Sally1, we'll say like Sally@test3.com. And we need to also specify our where. So what we're going to do is we're going to take our Sally, so our email, where it is Sally@test.com. So I'm taking my user with this email Sally@test.com and changing it to Sally@test3.com. Now if I save this, wait for it to run real quick, come down here, you can see our user has the name Sally and it has that updated email that's being printed out. So we correctly updated that user's email. And also down here, you can see we can pass in an include and a select, just like we could do with all of our other queries. So again, I'm not going to cover that because we cover that in all the other sections. Now update many is exactly the same as update, except it's going to update all the users that match a specific query. For example, we could say, hey, everyone that has the name of Sally, their new name is going to be new Sally. Now, if we save this and we wait for it to print in a second, you can see it's updated 3 users. And if we just try to find the first user that has the name of Sally, or new Sally, sorry. So where name new Sally, click save. You can see that we now have a user with that name of new Sally. So it's updated all of their names to that new name. The only important thing to know about update many is it doesn't allow you to do a select or an include. So that's really important to know. Just like with find many, you couldn't do that, or with create many, I mean, you also cannot do that with update many. Now, update does have a few fancy operations when it comes to the age. So I'm going to say update here where the name is Kyle, and I want to update their age. So I'm going to say age, and I want to increment their age by 1. So we'll say increment by 1. And you will notice we're getting an error here, and that's because when you do a single update, it must be on a unique field, and name is not a unique field. So let's do email instead, because I know the email field is unique. Just like that. Now if we save and give it a second, you can see our age for Kyle is now 28. Save it again, our age will be incremented to 29. We can also do decrement to remove 1 to bring it back down to 28. And we could change this to like remove 10. So now the age is going to be 18 when this resolves. We can also do multiply. So now the age is going to be 180. And we can also do divide, and then the age is going to go back to 18. So we can do these kind of fancy things to our age and just any number in general, which is really handy. Now, the last thing I want to talk about is the ability to actually add and connect different relationships to a user by updating them. Because I could come in here with update and I could say, user preference. And then in here, I could specify that I want to create a new user preference, and I could say email updates true, and that's going to update my user to give them a new user preference with this information. But what happens if I already had a user preference that I created? So let's actually do that real quick so I can show you what I'm talking about. I'm just going to comment this out. What I'm going to do is I'm going to say const preference equals await prisma.user preference.create. I'm going to create a user preference. And this user preference is going to have email updates set to true. And then we're going to console.log out our preference, just like that. And it looks like our data has an error with it. It says email updates true is not assignable to that type. I believe it's just an error that actually is not founded. Let me just make sure. Oh yeah, property user is missing. So we do technically need a user is what it is saying. Like you need to define a user for this. But let's just say that we didn't. We have this preference, and you can see we have an ID for it right here. I'm going to copy that ID. And then what we can do is just remove all this code we had, comment this back in, and instead of creating a brand new user preference, I want to link to this one that I just created. So instead of doing a create here, I want to do a connect. And for the connect, what I want to do is I want to search for where the ID is equal to that ID that we just created. So now what I'm doing is I'm taking this user and I'm connecting the user preference that already exists. So if we just give this a second, you can see it has now connected that user preference with this ID. And if I just come in here and I actually select this user by saying const user equals await prisma.user.find first, where the data name Kyle, this should be where, there we go. Now I click save. Oh, I make sure I do an include in here. I want to include user preference true. Now we should see it has that user preference, which the email updates of true. So we can actually connect different things by using this connect to connect already existing objects. Or what we can do is we can do a disconnect to remove existing objects. So instead of connect, I could say, you know what, I want to disconnect the user with this ID. And since this is a one-to-one relationship, we just need to say disconnect true. And that's going to automatically disconnect this user. Now I click save. You can see user preference ID is set to null, and it removed that connection. So you can either do a create directly in the update, or you can connect and disconnect things that already exist. And this ability to do connect and disconnects is actually available in create as well. So like if I was doing a create right here instead, I could still do a connect. I couldn't do a disconnect obviously, but I could use a connect right here as if I wanted to. So you can do connects anytime that you do creation, and you can do disconnect anytime you do updates. So now what we want to do is talk about the final feature that we have, which is the ability to delete. And we've already covered half of deleting, which is the delete many function. So if we say await prisma.user.delete, you can see we have delete and delete many. I'm going to cover delete first, just so we don't delete our entire database. Let's just come in here. We're going to get that user, and we can say console.log our user. So for our delete function, this works very similar to find. We just say where, and we can delete something based on a field. So we could say like where the name is Kyle. But you'll notice we get an error when we try to do that. And that's because delete only deletes one user, and it must be on a unique field. Our email is unique. So let's say where the email is kyle@test.com. Give it a save here, and you'll see it prints out the user that it just deleted. And now if we save it again, you'll notice there's no user to delete. So it's giving us an error. Hey, this failed. There was no user to be found for this delete. And we can do the same thing with delete many. Let's say I want to delete all the users that have an age that is greater than 20. So now this is going to delete all users with an age greater than 20. I click save, and you can see it deleted one user because only one user has an age greater than 20. Or if I just want to delete everything, I pass it nothing, click save, and now it's going to delete all the users in our database, and that's just 2 users. And that's all you need to learn about Prisma. Now, if you want to compare this to one of the most popular database providers in Node.js, you're going to want to watch my Mongoose and MongoDB videos. They're both going to be linked over here. I highly recommend checking them out to compare them to Prisma. With that said, thank you very much for watching and have a good day.